Water, the common solvent. Let's take a look at the structure of water. And the first thing we want to do is just write out our formula for water molecules. And our formula is going to be H2O. That means we have 2 hydrogen atoms for every 1 oxygen atom in a water molecule. So when we look at this molecule, we're going to have attractive forces holding our 2 hydrogens to our oxygen, and that force is called a covalent bond. So we would have something like this. We'd have our hydrogen atom covalently bonded to our oxygen atom. That means that they're sharing a pair of electrons. And that oxygen is going to be covalently bonded to a second hydrogen. And that gives us the structure of our water molecule. But when oxygen and hydrogen share pairs of electrons, they don't share them equally. Oxygen has a greater attraction for electrons than hydrogen does. So that means that the electrons are drawn closer to the oxygen side of the molecule. And what that's going to lead us to is our oxygen side of our water molecule is going to be slightly negative in charge. And we write that like this. That kind of figure 80 looking structure means partial negative. Our hydrogens are going to be partially positive because the electrons are being drawn slightly away from them and towards the oxygen. And what that does is it gives water a polarity. We have an unequal charge distribution within the molecule, so we end up with a slightly positive end and a slightly negative end to our water molecule. That explains a lot about the characteristics of water. We're going to look at how water dissolves other substances. We're going to talk about a term called hydration. And hydration describes how ionic solids dissolve in water. The positive end of the water molecule, the hydrogen end, is going to be attracted to anions in an ionic solid. Remember that anions are negatively charged, so they'd be attracted to the positive end of our water molecule. And the negative end of our water molecule, or the hydrogen end, would be attracted to the cations in the ionic solid, or the positive ions. So let's look at an animation of hydration. Okay, so here we have sodium chloride as an ionic compound. The little green balls represent the positive sodium ions, and the little purple balls represent the negative chloride ions. So what we're going to do is we're going to pour water into a container that's filled with sodium chloride and see how this hydration process takes place. So here come our little water molecules with the 1 oxygen and 2 hydrogen atoms. And when the water is added, the sodium chloride crystals are separated. Each positively charged sodium ion is attracted to the negative portion of our water molecule. And at the same time, the negatively charged chloride ions are attracted to the positive end of our water molecule. And the spheres of hydration that form around these ions keep them suspended in water. So when we talk about water, we want to talk about its solubility. And that means the amount of a substance that would dissolve in water. And the solubility of a substance in water varies greatly depending on what the substance is, depending on what the attraction of the ions are to the water molecules themselves. So we want to look at some solubility rules. The general rule for solubility is like dissolves like. And what that means is if our solute, the substance that's dissolving, is nonpolar, then it will dissolve in nonpolar substances. And if the substance that's dissolving is polar or ionic, it'll dissolve in polar substances. When we talk about solutions, they're considered to be homogeneous mixtures or homogeneous mixtures. And basically what that means is the substance that's dissolving will uniformly distribute itself within the substance it's dissolving in. Although the composition of that particular mixture can change. You can add a little bit of salt to water and the salt will distribute itself evenly. You can add a lot of salt to water and the salt will dissolve itself evenly. So let's look at the two parts of a solution. Our first part we're going to call our solute. And the solute is the substance that's being dissolved. The solvent is the substance that does the dissolving. So if we have salt dissolved in water, the salt is the solute and the water is the solvent. When we talk about solutes dissolving in solvents, a lot of times questions arise about the electrical conductivity of the solution. The electrical conductivity is the ability to conduct an electric current. Strong electrolytes dissolve in water and can conduct an electric current very efficiently. So if we were to look at barium chloride, it's an example of a strong electrolyte. Because if we take solid barium chloride and add it to water, it's going to dissolve in water. That hydration process is going to take place and our ions are going to be evenly distributed within the solution. And the presence of those ions will allow it to conduct an electric current. So strong electrolytes completely ionize or break up into ions when they dissolve in water. So let's look at some examples. Soluble salts like sodium chloride, potassium nitrate, and barium chloride are very soluble in water. They break up into ions, and those ions allow it to conduct an electric current, so it's a strong electrolyte. Strong acids are considered to be strong electrolytes, and you want to learn these now. We'll be using them throughout the year. So hydrochloric, hydrobromic, and hydroiodic acid are strong acids which are considered binary acids because they're made of two types of atoms. Sulfuric acid, perchloric acid, and nitric acid are strong oxyacids because they're acids that contain oxygen. But they all have something in common. When they dissolve in water, they break up into ions that can conduct an electric current. And when we talk about acids, and we dealt with how to name acids, we know that acids are substances that produce hydrogen ions in solution. So all of those substances will break up into ions, and the positive ion is a hydrogen ion. Strong bases contain hydroxide as their negative ion. They have a bitter taste, and they tend to be slippery. Weak electrolytes are electrolytes that break up partially into ions in solution, so they conduct a small current. If we look here, we've got an example of a structure. This is actually acetic acid, which is added to water, and we've got 1, 2, 3, 4, 5, 6 particles of acetic acid, but out of those particles, only one breaks up into positive and negative ions, as opposed to our examples before where they all broke up. So we're looking at a weak electrolyte. Weak electrolytes have a small ionization in water, or only a small percentage of their particles break up into ions. So they produce few ions when dissolved in water. The most common weak electrolytes are acetic acid and ammonia. And acetic acid is HC2H3O2 for its formula, and ammonia is NH3 for its formula. Non-electrolytes are substances that dissolve in water, but when they do so, no ions are produced. And since no ions are produced, no electrical current can be formed. The entire molecule dissolves without breaking up.